Alrighty, so welcome back to the Civil FE exam review. In today's video, we're going to be continuing our review in the Geotech Engineering section, and we're going to be focusing specifically on stability of retaining structures. And so I have a few practice problems for you all. At first, to me, these questions would look a little bit scary or throw me off just because of some of the symbols and because of some of the terminology. But as I have gone through them, they seem a bit easier now. So I want to share with you how to break these down so that they're not super challenging. All right, so let's look at number one. All right, so number one says, what is the active earth pressure coefficient based on the following retaining wall details? Okay, so you got a backfill angle. By that, whatever that is that it looks like a S, somewhat of a S, is equal to 30 degrees. Wall angle of internal friction is equal to 20 degrees. All right, determine the active earth pressure coefficient. Okay, so given the given information that we have is they give us a backfill angle, right? They give us a backfill angle. And they also give us a wall angle of internal friction angle. Okay, so we're trying to find what? Well, it says it twice in this question. It's the active earth pressure coefficient. So active earth pressure coefficient. So based on this, what formulas might I need to use? Well, I don't know what any of this is, so I'm just going to search active earth. Yeah, just active earth. It's only one thing that comes up when I search active earth. All right. And so Ka is equal to the Rankine active earth pressure coefficient. Okay, so I believe that this might be what I need. And so I find it says that it equals tangent squared. Whoa, you can't see anything. Okay, so let me just move me, but then you should be able to see everything. Okay, so here at the bottom, all right, we have Ka, which says it's the Rankine active earth pressure coefficient, and it is equal to this tan squared, and in parentheses is 45 minus phi divided by 2. Well, what is that symbol, phi? Well, we take a closer look. Just looking through the geotech section to see if I can find what phi is. All right. So this is harder than I thought it was going to be. So, phi is angle of internal friction. Okay. So which angle am I going to be using? Well, I'm going to be using the angle of internal friction, not the backfill angle, for this. So now we solve, right? I think I have everything that I need. and I have the formula that I'm going to need is going to be Ka is equal to tangent squared of 45 degrees minus phi, right, angle of internal friction, 20 degrees minus over 2. And when I solve for that, I get my active earth pressure coefficient to equal 0.49 for A. All right, let's look at number 2. Okay, so number 2 says, what is the passive earth pressure coefficient based on the following retaining wall details? So C is equal to 0 and phi is equal to 30 degrees. Okay, so given information is that they give us phi, which in this case, for according to the data, and since we're already in this section, right, of the, since we're already in the geotech engineering section, we know that phi is going to be the angle of internal friction. So they give us angle of internal friction. And what is C? All right. C is going to equal your cohesion. So they also give us cohesion. Okay. So anytime you're in the retaining wall section, you're going to be roughly in the area where it tells you what phi and what C is. If you don't know how to get there, the first thing we could do is search passive earth pressure, or passive earth, and you can see that this is the only place that it could be. So we're trying to find, right, the passive earth coefficient. Now the formulas that we would need would be this is Kp is equal to tan squared, right, of 45 degrees plus phi divided by 2. So this one is kind of similar to the problem we did before where it had active earth pressure, or we were solving for the active earth pressure coefficient. So formula needed, just copy it from the handbook. K, so P is equal to tan squared 45 degrees plus phi divided by 2. Okay. Phi is 30, so the only thing we need to do is just plug and chug. So for that, I end up getting 3 for the passive earth pressure coefficient. Let's see. All right, let's look at number 3. So this one says, what is the at-rest earth pressure coefficient for a normally consolidated soil with an angle of internal friction of 16 degrees? So they give us the angle of internal friction, right? They also give us that it's normally consolidated. And so we're trying to find what? We are trying to find the at rest earth pressure. Okay. So if we're trying to find the at rest earth pressure, how do we get that? Well, at rest earth. I'm searching at rest earth. Move my head so you can see. So the first thing that comes up, and the only thing that comes up, is K0. Zoom in here. So at rest forces on wall per unit length. So K0 is identified as the at rest pressure coefficient. And so K0 can be, you can solve for it for a normally consolidated soil or for over consolidated soil. And so we have, right, in our equation, a normally consolidated soil, which is very important. And then we also know what is phi, right? Well, phi is going to be the angle of internal friction. So we have everything we need to be able to solve this equation. So K0 is going to equal 1 minus sine of phi. And so K0 is equal to 1 minus the sine of 16 degrees. 16 is my phi, or my angle of internal friction. And when I solve for that, I end up getting K0 is equal to 0.72 roughly. All right, so this concludes the stability of retaining structures or retaining walls. Section is not super hard. You just have to know what to plug in and where to go to solve. So in the next section, we're going to be looking at shear strength and go through a few different practice problems on those. So I will see you in the next video.